Okay, this is May 2008, question 8. We're given that the displacement of a particle from the origin is given by this expression here. So the displacement at time t is given by this expression, which we'll call x. And this is valid for times of t between -4 and 6. Don't worry about t being negative. What we're really saying there is that at time t is 0, we're considering the motion of the object before that point and the motion of the object after that point. Part 1, write down the displacement when t is 0. So we simply substitute t is 0 in here, and that clearly gives us x is 10 metres. So that's part 1. Part 2, find an expression for the velocity of the particle. Well, we know that velocity is change in distance over change in time. In other words, velocity is dx dt, change in distance or displacement over change in time. And if we differentiate this, we get 36 plus 6t squared minus, I beg your pardon, 6t, isn't it? Minus 6t squared. Okay. Part 3, find an expression for the acceleration of the particle. Well, we know that acceleration is change in velocity over change in time. So we can find that by differentiating this expression. So that gives us 6 minus 12t. Part 4. Find the maximum value of v in this time interval. Well, here's our expression for v, and we know that to find the maximum value of a function, we differentiate it and put it equal to 0. Well, we've already differentiated this function here. So if we put this, which is dv dt, equal to 0, then we can see that that gives the time of t is 0.5 seconds. So after 0.5 seconds, the velocity will be at its maximum, and of course we can calculate what that will be by simply substituting in that value of t, and we find, if we put in 0.5 into here, that we get v is 36 plus 0.5 times 6 is 3. Now 0.5 squared is 0.25, and 6 times 0.25 is 1.5, so minus 1.5, and that gives us an answer of 37.5 metres per second minus 1. Moving on to part 5, show that v equals 0 only when t is minus 2 and t is 3. Well, we can show that v is 0 by putting 0 in place of v. So we can put 0 equals this. So that gives us, so this was part 4, and we're now on part 5. So if we put v equal to 0, that means we have 36 plus 6t squared, 6t minus 6t squared equals 0. And if we solve this, we get two answers for t. T is equal to minus 2, or t is equal to 3. And then to figure out the value of x at these times, we simply put these two values for t into the original expression for x, and that gives us, at time t is minus 2, we have x equals minus 34, and when t is 3, we have x equals 91. Alright, so that's part 5. Part 6, calculate the distance travelled by the particle from t is 0 to t is 4. Well, we know that when the easiest way to find the distance travelled would actually be to basically put in 0 in here, and then to put in